Alright, this is adding, subtracting rational expressions. These are a little more complicated because you do have to get a common denominator in order to add or subtract any fraction. So your first step, just to try to avoid some extra work, is if you can simplify or reduce any of your fractions in the beginning, generally you want to do that. Step 2 is to factor your denominators so you can try to get the common denominator. Step 3 is going to be to get that common denominator. Step 4, you're going to go and add and subtract, because if you're adding or subtracting, that's the ultimate goal, but you first have to get that denominator in common before you can do that. And step 5 is to simplify. And I do want you to understand, with that note, that in your final answer, your numerator is going to be simplified, but the denominator is typically left in factored form. Alright, so on example 1, let me adjust this camera. Okay, example 1, you have a common denominator. So if you have a common denominator, great. All you have to do is add. So 5 over 2x plus 3 over 2x is simply 8 over 2x. But now that we've added those, can 8 over 2x be simplified? Sure, because 8 over 2 is 4. And so our final answer is 4 over x. Now let's not forget those excluded values. What could x not equal? Well, remember, you can't ever divide by 0, and if x were 0, you would be. So 4 divided by x, where x can't equal 0. Example 2 is a little more complicated. It does already have a common denominator, so thank goodness we don't even have to worry about that. But even though it has a common denominator, what that means is, because it's a common denominator, you can unite this as one fraction. So what that is 2x squared minus 3 minus 8x plus 5, and then all of that is over x plus 1. So what you need to do now is distribute that negative. So that becomes 2x squared minus 3 minus 8x minus 5 all over x plus 1. And then that gives you a final simplified answer. We just need to combine our like terms. So this is 2x squared minus 8x minus 8 all over x plus 1. And our excluded value, what could x not have equaled? Well, our only denominator this whole time has been x plus 1. If x were negative 1, we would have a denominator 0. So x can't equal negative 1. Okay, going into examples 3 and 4, these are going to be our first ones where you don't have a common denominator. So these get a lot trickier. On example 3 is the reason I have number 1 up there. If you can simplify or reduce, you absolutely want to do that. Don't go crazy trying to get a common denominator, because sometimes it helps to make things smaller first. 4 over 8 reduces to 1 over 2. And 3 over 6 reduces to 1 over 2. Now LCD means the least thing that they can possibly have in common. But you can't take away things, really. You can only make things bigger. So they both have a 2, but what this one is missing is an x. So the least common denominator that we can possibly have is going to be 2x. So what that means is we need to multiply this one, top and bottom, by x. So that gives us 1 over 2x plus x over 2x. Now that we have a common denominator, this is a whole lot like number 1, only here we just had numbers so we could combine them. But if you have a variable and a number here, you're done. There's nothing you can do. So that gives you x plus 1 over 2x. And x could not have equaled 0. Okay. Example 4, looking at your LCD. The factoring the denominators to find the LCD, that's going to come into play on the second set of examples more than this one. Here, this is x plus 4. That's a linear factor. It's understood to be in parentheses. And here you have the constant 4. So they're prime relative to each other. So your LCD here is simply 4x plus 4. So what that means is, as we try to get a common denominator, we're going to need to multiply each of the fractions by the denominator in the other one. So since this one has x plus 4, it needs a 4. A lot of students think about this as a have versus need game. So it has the x plus 4, it needs the 4. This one has the 4, so it needs the x plus 4. Alright. So what this is, 2 times 4 is 8, so we have 8 over 4 times x plus 4 plus x plus 4 over 4x plus 4. Now that we have the common denominator of 4x plus 4, we can unite our numerators. So that gives us, let's see, going around down here, that gives us 8 plus x plus 4 over 4x plus 4. And now we just combine our like terms. 8 and 4 is 12, so we have x plus 12 over 4x plus 4. And we still have to always keep in mind those excluded values. What could x never have equaled? Well, it never could have been negative 4. Because if you set that equal to 0, and x would be negative 4 and 4 gives you 0. Alright, so that's the first set. The key thing is getting your common denominator, and whatever you're missing to make it common, you multiply the numerator and the denominator by that. Alright, next set.